VLSos here. This is a video lesson on parallelogram and trapezoids. Parallelogram and trapezoids are basic shapes, but their properties are a little more sophisticated than squares and rectangles and triangles. I'm going to draw a parallelogram. And we'll use these drawings in notation to highlight the properties of these shapes. Parallelogram has four sides. It's a quadrilateral because quadrilateral means a shape that has four sides, but a parallelogram has more properties that are reliable, that we may know about it because it's a parallelogram, than just having four sides. A trapezoid is also a quadrilateral, but it has different properties than a parallelogram, so we have a different name for this kind of quadrilateral. I'm going to draw a trapezoid. Four sides, just like the parallelogram, but different properties. I'm going to use notation now to highlight the properties of these shapes. If I put a tick mark in the middle of this side of the parallelogram, and the same number of tick marks, in this case 1, on this side, I've used notation to show that the measure of those two sides are equal. I may not know what the measure is, but I know if I have the same number of tick marks on two different sides, then those two sides are equal in measure. I could use the same idea, but I'm going to put 2 tick marks on this side and 2 tick marks on this side. That's notation to say that those two sides, no matter what their measure, those two sides have equal measure to each other. Now the side with 2 tick marks does not have an equal measure to the side with 1 tick mark because there's a different number of tick marks. Parallelogram has this property that there are 2 pairs of equal sides. We could also use a notation called a chevron, which looks like an arrowhead, and put an arrowhead on this side, and if I use the same number of arrowheads or chevrons on this side, then that is notation to say that those two sides are parallel to each other. Parallel means that these two sides remain at an equal distance. If there are lines that were extending, then they'd never intersect. They run side by side forever. But these lines are sides of a shape. They don't extend forever, but they're still parallel to each other. Now I could put 2 chevrons in the middle of this side and 2 chevrons in the middle of this side, which is notation to say that those two sides are parallel to each other. They're also equal to each other with the tick marks, but the chevrons is a different symbol. 2 sides that have the same number of chevrons are parallel to each other. These 2 sides are parallel and equal in measure. These 2 sides are parallel and equal in measure. So we could say that a parallelogram has 2 pairs of parallel sides, which is why and how it gets its name, parallelogram. We could list the properties that all parallelograms will have: 4 sides, 2 pair of parallel sides, and 2 pair of equal sides. Let's do the same for trapezoid. trapezoid has a pair of parallel sides. If I use a chevron on these two sides, that's notation to mean that these two sides are parallel to each other. I'm not going to use the notation on these two because these two are not parallel to each other. Trapezoid has only one pair of parallel sides. Now, a trapezoid can have sides that may be equal, but it is not necessary to have any sides of a trapezoid be equal in measure to any other side. So I don't use notation for that as well. In fact, a trapezoid, if we were to list its properties, has four sides, just like a parallelogram, but only one pair of parallel sides. That's it. We know that we can find the perimeter of a shape by knowing the measures of the sides and adding them all together. But what we're going to put in our notes is a formula for the area of these shapes. Parallelogram's area is the measure of its base times its height, which is the same formula for the area of a rectangle. But a parallelogram's height is not the same as one of its side measures. We could label one of the sides to be the base, call it B, but the height of a parallelogram, just like the height of a triangle, has to be the measure perpendicular to the base. So I've drawn a dotted line that meets this side that we've called the base at a right angle. That means they're perpendicular, the dotted line and the base. And the height is the measure of that line that's perpendicular to the base. Notice that the measure of the height in a parallelogram is not the same thing as the measure of its other side. But if we were to find these measures for the height and the base, we can put them into this formula, multiply them, and find the area of the parallelogram. The area for a trapezoid is more sophisticated. Trapezoid will need to do a similar thing as that we did on the parallelogram to imagine a height of the trapezoid that meets the base, in this case we'll call it B, at a right angle. The measure of the height of the trapezoid, just like the parallelogram, has to be found perpendicular or meeting at a right angle to its base. And we need that height to calculate the area of this trapezoid. But a trapezoid, we also have to account for the other side that is parallel to the base that we've labeled as part of the formula. In fact, we can consider a trapezoid as having two bases. We can't use the same symbol, B, for base because these lines, these sides, do not have the same measure. So we can't use the same variable because it would suggest that they have the same measure. We're going to modify and call one of these B1 and the other parallel B2. It may be odd to say that a trapezoid has two bases, but we have to remember that the side that is a shape's base does not necessarily need to be at the bottom. The word base suggests bottom, but a trapezoid has two bases and they don't need to be at the bottom. It's only possible for one to be in the bottom of the shape anyway. So with this labeling, the two parallel sides of a trapezoid, one being base 1 and the other being base 2, and the height, we can complete the area formula as the sum of the bases, b1 plus b2, then multiply by a half, and also multiply by the height.